Hi, it's David again from the DroneSense Customer Success Team. Today I'm going to be covering flight planning, and this is a video that I think I made about 18 months ago, and in that time DroneSense has released some really exciting new patterns, specifically related to search and rescue. So let's go ahead and begin. We are here in the DroneSense mobile application. I'm logged in. Now, first thing to note, in the upper left-hand side of the screen, as I tap on the flight planning icon, we can see setup. So currently my drone, which is a Mavic 3 thermal, is connected. It's geolocated. I do want to let you know that it's actually not necessary to have a drone connected when you create these flight plans from the mobile application. You can actually do it and save them to the cloud and then connect the drone and pull them back down from the cloud to execute the flight plan. Now, the reason I'm showing you this screen is as we come over to actions here, you're going to see there are no flight actions available. All I need to do is go ahead and tap on the inset map, bring the map to the primary view, and all of those flight planning elements are going to populate. It's important to remember, again, going back to camera view, you've got to be in map view to be able to conduct or build the flight plans. So we're going to go ahead and start with the waypoint here. On the upper left-hand side, we're going to tap. We have a speed here at 2 miles an hour, 79 feet. So what I do is let's go ahead and put our first waypoint on the map. Now, once I place the waypoint, it did come to our predefined 10 miles an hour, 150 feet in altitude. I'm going to scroll down. I'm not going to make any other changes here, except end of waypoint action. I want to show you, you can select hover or next plan item. In this case, we are going to do next plan item. I'm going to add that to the plan. Now, what I'm going to do is go back to actions. We're going to add a second waypoint. And let's say we're going to fly along this kind of, this is an irrigation ditch here in Boulder, Colorado. Same thing. We have next plan item. We're going to add to plan. Now, here we're going to add a third waypoint. Let's put that one a little further down here. Stand by. And we're going to go ahead and drop that one here. All of those parameters are fine. And there we go. So what we have is, this is a way to basically build out a predefined flight path. Think about it for a special event such as a parade. If you have a flight plan like this based on a series of waypoints built up around a parade site or anything like that, it really is a great tool to do custom flight planning like that. Okay, now what we would do then is we could execute the flight plan. If I click on the play button, it's going to ask me to go now, but I need to select any numbered circle to begin. It's going to default to that first flight planning element, obviously number 1, but I'm going to cancel that. We're not going to launch the drone quite yet. Okay, so that's how you build out the waypoint flight plan. I'm going to go ahead and clear the map. There we go. Now let's go ahead and hop back into our flight plans. This is one that I hope most of the DroneSense customers are very familiar with already. This is one that's been in the inventory for some time. Of course, we have the traditional orbit. So we select the orbit. It brings us into the Actions tab here. Again, default 10 miles an hour, 150 feet altitude. And I'm going to go ahead and click that. And it will turn the radius into a 328-foot radius circle. Of course, I can place my finger on the center, and I can drag this to, precisely place it where I'd like it to be. And then, of course, I can drag out that side slider as well to make that bigger or smaller as well. Now, we can select the drone heading. We can choose where we want it to look, and we can also select the rotation. And also, we can select it to take photos, including what gimbal angle we want this camera to be at. In this case, it is going to be defaulted to 45 degrees. Now, I want you to be aware that the trigger for the photographs being taken is not an angular measurement around the circle. It's actually based on time. So if you are doing an oblique data set for a mapping mission or something like that, generally this circle is going to be much, much smaller. But we can come here and we're going to go back to our speed, and we're going to drop that down, let's say, to 3 miles an hour. And let's actually make that a lot smaller. Let's say that we were just doing maybe an intersection for a fatal accident. And as we scroll down, now the trigger, it is 4 seconds in between photos. So the interval is 4 seconds. The slower the drone is traveling, the more photographs and the higher the overlap are going to be captured. All right, in this case, we would just go ahead and add it to the plan. And there we go. We have our first flight planning element. We're going to come back and let's go ahead and clear this flight plan as well. We're going to come back into our actions. Now we have the traditional survey method. This is what is really the bread and butter for forensic mapping, crime scene reconstruction, accident reconstruction, mapping and modeling, that kind of thing. So let's go ahead and we're just going to zoom out here. This is going to be a little bit outside of our purview. We're not going to execute this mission, but let's just come over here, and it's going to drop the single pass onto the grid. Now, if you take a look here, we have all of these parameters for the survey. The preset is going to be Pix4D React. I have custom 3D ortho and then a search and rescue, and we're going to talk about that in just a minute. But if I go to the 3D ortho, that's going to go ahead and, again, make that map where it is bidirectional. So it's going to be the grid map. And this is really going to be appropriate for capturing that Z-axis data for your cloud point for, again, reconstruction, mapping, and modeling. Now, we have all of these parameters, the speed, altitude, ground sampling, distance, and gimbal. And in this case, we'll leave it at 10 miles an hour. 150 feet is fine. The ground sampling distance, if you look, as I change the GSD, that is going to change the altitude of the flight. So if you have a particular ground sampling distance or resolution that you need to achieve, you can go ahead and change that. Here for the 3D, it's going to default to a gimbal angle. You may be flying between 55 and, let's say, 75 degrees for this type of data set. Again, completely up to you. Now, very important and a huge upgrade into the DroneSense mobile application is the ability to now add terrain following. This was a very recent update for the DroneSense map, and it's been a great addition into the platform. So again, this is going to keep the ground sampling distance consistent as the drone is flying and mapping over mountainous or hilly terrain with a large delta in elevation. All right, here we're going to come over to the overlaps as well. This is where we set the percentage of the front and side overlaps for the camera capture. It looks like we default to 75-60. Obviously, that's going to be very dependent upon the scene and what you need to capture. Obviously, that's going to get to be an enormous data set for such a large area as I have selected here as well. Now, the auto is basically the survey angle. So I can angle that survey, or I can just go back to auto. The 3D mode is what we talked about, where that is going to enable the grid or the second pass to capture all of that additional information. And then finally, we can actually disable take photos, and that really makes it consistent with that search and rescue pattern as well. Now, as I come back to survey, and again, I'm just going to let this run. You see that I inadvertently cleared that. Please learn from my mistakes. It gives you a survey time here as well. So let's go ahead and kind of build this out again. We are going to make this 3D ortho, and then we're going to change our overlaps. And let's make those overlaps quite a bit larger there. And as we come up here, we're going to give you an estimated flight time. Now, if you are in a mission where there are multiple batteries required, at the point at which you receive the low battery warning, we are going to the drone will stop. A marker will be placed. The drone can return home, and when you're ready to resume the mission, you can simply select the marker that was placed along the flight path and resume the flight from there. Again, a great addition to DroneSense here that we had recently included in the software. Okay, let's go ahead and clear this one as well. And as we come down sector search, this is an exciting one. This is something that we recently enabled based on the Dr. Robert Coaster bike wheel pattern search and working with the Norwegian National Police. What we're going to do is go ahead and just tap here on the map. This is going to bring up a predefined path. We have the speed at 6.7, the altitude, the radius. Now look at what happens as I adjust the radius. That altitude is adjusting. These are all scaled very precisely. And so as I alter the altitude, it's going to alter the radius. You can still set the speed, you can set the gimbal angle, you can choose whether you take photographs or not, and then terrain following is default on for this sector search. And I want to show you this as well. So let's say that this is a search that we want to add to the actual flight plan here. Now, we have that as one flight planning element, which is here, the sector search. Now, I could come in and add a second plan. Let's say we had two areas of responsibility for this drone. So let's come back into Actions. We're going to select the sector search again here. And I'm going to place a second sector search here. And for whatever reason, this is just appropriate for the mission at hand. We'll make that one a little bit larger. We have all of those parameters. I'm going to go ahead and, let's say, take photos on this, and then we are going to add to the plan. So you see we have our home point. We have the drone now flying to the sector search pattern number 1. And then when it concludes that, it will fly to sector search pattern number 2. So what we want to do, though, is let's say we want to save this to the cloud. I'm going to click Save. Now, we're going to name this, let's call this sector search. Okay, flight plan sector search, perfect. Now, I have the check there enabled, save to the cloud. We have a lot of flight planning elements in this training environment here, so it's going to take just a minute to upload to the cloud. You should not experience such a long wait time. I am also on a reasonable LTE signal here in Boulder County, Colorado, and you see that now that has disappeared. We could certainly execute this flight plan right now, but I am going to cancel that. Now, I'm going to come back, and I'm going to clear the flight plan. Now, I've already saved it to the cloud, so I'm going to clear it. Now we're going to come back. Let's say we're in position. We actually want to execute that flight plan. We were driving to the scene. We knew exactly what we wanted to do. So now I can go ahead and load. And again, give this just a minute here. We have a number of flight plans up in this environment. Should really go through and clean up this organization. This is a pure training environment for the DroneSense customer success team. So we'll give it just a minute here to load. And there it is. And we're going to go ahead and sort by date created here. And there it is. So the flight plan sector search Spraggs. We're going to confirm that. And there is that flight plan now pulled back down from the web and ready to execute. All right, now as we come back into our actions, we have talked about a number of these already. We have a few more to go, and I'm going to talk about line search next. The line search is, again, a new search and rescue pattern for DroneSense. And let's say we had a person search along this kind of trail and ditch, irrigation ditch here. So what I'm going to do is I am going to drop the first marker. All right, stand by here. This is user error. I'm going to go ahead and select line search. There it is. Tap on the map right there. There is our first element. Now I'm going to go ahead and pull this element around here. Now what I can do is I can basically also have waypoints. Here I can touch on the screen. Now you want to touch and hold. So I'm touching and holding for those additional elements to then load onto the map. So here we have a double pass. Remember, the blue lines are the flight path that the drone is going to operate on when it's in this mission. Now we have the speed, the altitude, the width, so I can adjust the width here. I can make it bigger or smaller. Again, just be aware of the overlaps as well. That may be dependent or will be dependent upon the field of view of your camera as well. You have the ability to take photos as well. Again, because this is a search and rescue pattern, it is terrain following, and it can be turned off for the terrain follow function as well. Once we come back, let's go ahead and add this to the flight plan here as the next plan item. There we go. So now we're making a little bit more complex flight plan. We're going to come back to actions. We have talked about the line search now, the parallel search. This is going to be rather similar to the survey mission, although again, this was purposefully designed for the search and rescue operation. So let's go ahead and tap on the map. We're going to get that initial parallel search in. The speed, the altitude, all of that is user adjustable. I can adjust the distance between legs here on the screen, or I can do it here through the slider. We have the width, we have the length, all of those parameters you'd expect you could change. You can do that right here. Again, gimbal angle to take photos, as you know, terrain following because it's a search and rescue pattern, that is enabled as well. Of course, we can angle this pattern as well. Now, we do have an option for single pass versus double pass here. That's going to basically have the distance between the legs. And then we also can take you now to this grid pattern. Again, that's looking very similar to the survey mission. In fact, you could say we can take photos here as well. Now, what you cannot do here is set the specific overlap, the front and side overlap, to ensure that you're getting the data required to make sure you have adequate, automatic tie points in your software, whether it's Pix4D or whatever you're using. So I do not recommend using this pattern for a survey mission. Go ahead and use that dedicated survey mission. I think that's really important as well. All right, and let's go ahead and let's just scale this back a little bit. We'll add this into the plan as well. And there's our fourth flight planning element. And we're going to go back to actions. And the last one I want to talk about is the grid search. And what you're seeing here, it says, please add a parallel search to the map. So I'm going to click on that. Okay, so what this is essentially the parallel search where we have created this as that double grid. So I'm going to clear this. Let me cancel this one. I'm going to cancel that. Let's come back and I want to show you again. So the parallel search, right? Same thing. I'm going to click on that. That's going to bring it up as the single leg parallel search. Now here we could go to the grid mode, but we're going to go back to the single. And let's go ahead and clear this. Now if we come down to the grid search, I'm going to tap on that. That's going to automatically create the grid, even though it does say parallel. And we have the mode single, double, and then back to grid. So essentially we're giving you two ways to get to the same flight planning element, just with those predetermined factors already set, i.e. the single pass or double pass versus the grid. All right, and we are going to cancel that. Now, this is important. The last thing I want to mention is the home point here. We have a home point. Now, I'm going to tap this home point right here. Let me get that on the map. Stand by. Okay. And let's see. Okay. So take a look at the behavior here. It is not allowing me to set the home point other than the home point where we launched from. And I think that's an important point. What this is this is not a dynamic home point. This does not allow you to set a new home point relative to your place where you launched. Now, if the drone were not enabled, let me repeat that again. I want to make sure I'm clear. So this home point does not allow the drone or will not allow the drone to do a return to home to the new home point that you define. It is not a dynamic home point. This would be considered an end of action, essentially an alternate end of action for the drone at the end of the flight path. Now, in this case, I have the drone geolocated. The drone knows it's going to come home. But if I were building this flight planning element or these flight planning elements without the drone, it would let me set an approximate home point for that mission as well. Okay, so let's go ahead and do this. I do want to execute, and I know this video is getting quite long, But let's go ahead and execute this. I think it would be neat to show the terrain following capability. So what I'm going to do is I'm going to come down, and we're going to select 4 right here, and I'm going to say go now. We're just checking the airspace. I do have a visual observer on site with me outside of the vehicle. I'm here inside the vehicle, and we're going to go ahead, and I have the thumbs up, and we are going to now execute this flight plan. And we can see we have terrain following, and that drone is now going to go ahead and go up to altitude, and it is going to transition over to its beginning point on that grid search. And remember, that's the parallel search that is now set as a grid. So we're going to let that drone fly. We'll give you a little view here of the Boulder Valley. That is El Dorado Springs State Park in the distance for anybody that is into rock climbing. It's a kind of a nationally renowned rock climbing area here in Boulder. All right, and we're going to come back into our map view. Now, one thing that I want to point out is the ability to drop markers from the camera view as well. And let's wait for this to get into position. You can see we have terrain following. And the reason I chose this is I'm hoping we're going to see a little bit of a delta in our MSL, height above terrain, etc., as that drone is going to follow the kind of natural ridge line there that you can see in the camera view. There's a little bit of a gentle slope or ridge as this drone now is coming into position. We're going to go ahead and zoom in. We can see that sensor point of interest, the breadcrumbs. It's now transitioning here. And let's say that we see something that we really want to capture. We're going to go ahead and drop a marker. We're going to say targeted search right there. We're going to go ahead and just drop a pin or marker right there. There is the marker on our map view as well. Now let's take a look here. I'm hoping, let's see, yep, it comes up through this leg. We're not going to quite see it as much. You can see some very minor changes in the height above terrain. I could have been more thoughtful about this and actually started it on one of the other legs. And so let's do that. I'm going to stop this flight plan right now, and the drone is going to hover. Now, do you see when I stopped it? This is a perfect example. We have that marker now with S, that stop point. This now is when we could fly the drone home. We could do a battery swap and then resume the mission by selecting that S or that marker point directly, that stop point of the mission. Now, in this case, we're going to go ahead and play it, but I'm going to select a different leg here. No, let me select this leg. There we go. For the right direction. Let's go ahead and play it. We're going to say go now. And stand by. We're going to let this drone reposition. There we go. We have our terrain following indicator again. And then take a look at the telemetry in the lower part of the telemetry bar. Take a look at the height above terrain, and all of those data parameters are changing exactly like they're supposed to be. So that drone is altering its flight path to maintain a consistent distance between the ground-based obstacles and between the ground and its position. So there we have the terrain following enabled. And we'll just let it get in. We'll do one more leg here. We'll let it get one more leg in to see those differences in the AGL and height above terrain. So again, we should be seeing that AGL bump, but we want to see that height above terrain generally remaining consistent. Now this drone is traveling very quickly. I may not do something that quick, but again, to be clear, we want to see that height above terrain remain generally consistent, which is going to keep the ground sampling distance the same, while seeing the AGL change as the drone is moving up and down to follow that ridge line. Let's just come back into that camera view here as well. I'm going to angle that gimbal up and see where we're looking here. Okay, looks good. Okay, now I'm going to go ahead and stop the mission. We're going to return back home. And I do want to say this again, there's so much to the DroneSense ecosystem. I hope you found this video helpful. This is much, much longer than we've normally recorded for this. The key is to get out and fly, get that muscle memory, get that comfort, and get out there and build flight planning. And really, your creativity is the only limitation in what you can do with this. And let's go ahead and we're going to stop this. And we are going to play. And in this case, if you see the home button is now highlighted, we're going to go ahead and bring it home. This is going to start that RTH process. We've got good visual confirmation on the screen. Airspace is clear. My visual observer is has left the field of view. All right, we're going to get this drone back home. We definitely have some shimmy on this landing here, so that's interesting. All right, and we are good to go. Thanks for watching, everybody. Take care.